Just like we did with addition, we're going to think about subtraction in terms of counting and in terms of lengths. So in terms of counting, I might think, what is 7 squares minus 3 squares? In terms of counting, we think of subtraction as taking away. So I'm taking away 1, 2, 3. 1, 2, 3. I take those away. What's left? 1, 2, 3, 4. What's left is 4 squares. And notice, instead of just drawing a nice picture of 4 squares, I copied these 4 squares that are left. That's what the subtraction gives us. Notice, in the whole numbers, without coming up with some new numbers, we can only subtract bigger minus smaller. Soon, we'll have some more complicated numbers available to us, and then that's going to change. How do we understand subtraction in terms of lengths? Again, we want to see, in terms of lengths, what is 7 minus 3. So I'm going to draw the length 7, and I'm going to draw the length 3. In terms of length, I'm going to say that 7 minus 3 is going to be the length from the end of 3 to the end of 7 in general. In terms of lengths, the difference is the length from the end of the second number, in this case 3, to the end of the first number, in this case 7. So I draw from the end of 3 to the end of 7. It's hard to tell, right, how long that is. To figure out what this length is, I need to pick it up, and I need to move it so that it begins at 0. And that way I can see how long it is. And now I see this is the length that begins at 0 and ends at 4. So this is the length 4. Just like with addition, of course, we're not doing this to find out what 7 minus 3 is. We know what 7 minus 3 is. We're doing this to understand what it means to be 7 minus 3, because that's going to help us when we get to more complicated numbers. Now, looking at this picture of lengths especially, this looks a lot like the picture we would use for a different piece of arithmetic. This looks just like the picture of 3 plus 4 is 7. Coincidence? No, this is not a coincidence. Addition and subtraction are very closely related. In fact, we can think of the question, 7 minus 3 equals what, as being the same question as 3 plus what equals 7. So the question, what do I get if I take 3 from 7, is the same as the question, what do I add to 3 in order to get 7? Keeping in mind that addition and subtraction consider the same questions, it won't be surprising to learn we always subtract the same kinds of things. 7 squares minus 3 squares equals 4 squares. 7 hours minus 3 hours equals 4 hours. 7 elephants minus 3 elephants equals 4 elephants. And so on. This also helps us just like it did with addition when we go to subtract large numbers. If we want to subtract, for example, 26 minus 12, well, 26 is 2 tens and 6 units. 12 is 1 10 and 2 units. 2 tens minus 1 10 leaves us 1 10. 6 units minus 2 units equals 4 units. 26 minus 12, 1 10, 4 units is 14. Just like with addition, when we subtract, we line up the places and we subtract down columns. Notice that in subtraction, it's necessary to write the second number on the bottom. Now, remember that in the whole numbers, it's only possible to subtract bigger minus smaller. What if we wanted to subtract 81 minus 29? Right? We have 8 tens and 1 unit. We have 2 tens and 9 units. But when we go to subtract the units, we can't do this in the whole numbers. So what should we do? Do we want to wait around until we have more numbers to work with? No. Because, of course, that first number doesn't just have 1 unit, it also has 8 tens. In fact, 8 tens and 1 unit, that's the same as 7 tens, an eighth ten, and 1 unit. Together, 7 tens and 1 10 make up 8 tens. But that in turn, right, this 1 10 is 10 units. We have 7 tens and 11 units. So instead of thinking of 81 as being made up of 8 tens and 1 unit, we think of it as made up of 7 tens and 11 units. So instead of 1 unit, we have 11 units. 11 units minus 9 units is 2 units. Now when we go to the tens place, we have to remember that we did that. We have 7 tens minus 2 tens equals 5 tens. 81 minus 29 then? 5 tens and 2 units, that's 52. The way we actually write that out is, again, we line up the places. When we go to subtract down the columns, though, we can't do this. And so instead, we take one of our tens and we split it up into 10 units. And then we subtract 11 minus 9 is 2, 7 minus 2 is 5, and we get our 52. This step, where we split up one of our tens into units, this step is called borrowing or renaming. Notice that renaming is the same word that we used in addition, right? Here we're taking 1 10 and saying that it's the same as 10 units. In addition, we went the other way. We said 10 units was the same as 110. Right. Again, we see that relationship between addition and subtraction on display. We're making a similar move, but in the opposite direction.